Welcome to Sports, Clicks, and Politics with your hosts, Ben Husong and me, Sean Hannon. I'm excited to welcome to the show an extremely committed researcher. He's the founder of the Mobile Observatory Project, the organizer of the yearly Observing the Frontier Conference, the man behind spaceweathernews.com, magneticreversal.org, and quakewatch.net. He's the author of Weatherman's Guide to the Sun, the creator of the Disaster Prediction app, and the operator of Suspicious0bservers YouTube channel with, today I checked, 476,000 subscribers. Ladies and gentlemen, the earthquake whisperer himself, Mr. Ben Davidson. Mr. Davidson, thank you for taking some time out for our little program here, and I want to welcome you to Sports, Clicks, and Politics.
Thank you very much for that wonderful introduction. And that's also a new nickname. I'm going to have to steal that one.
Well, it's deserving. I mean, you are a very busy man. Like I said, all that information out there, a lot of data to digest. So let's get right into this. Let's talk earthquakes here. Let's start here. That seems to be something that you've touched on a lot recently, in large part because I feel like you're getting some, let's call it institutional validation of some of the work. So let's talk earthquakes and why does the sun trigger earthquakes?
Sure. It's pretty simple. Everybody knows there's water in the ground, there's crystal in the ground in the rock, and there's a lot of metal. All of these things are very reactive to what they call electromagnetic force. This is obvious to folks if they know how a magnet works with metal, or if they know anything about static electricity and how that can make things move, attract things, make your hair stand up. All of these things can apply to the Earth's crust as a whole, depending on the different electromagnetic environment and inputs that the sun is giving it.
And so we're talking electricity here, yeah? So
basically, yes.
So is that coming from inside of the planet, outside of the planet? Like where is the electricity, if there's an origin of it, what are we looking for? What is the genesis of the electricity that's triggering these earthquakes? I mean, is it a external force?
So there is electricity just sort of germane to the Earth. I mean, you know that if you've ever seen a lightning storm. But in terms of what the sun does is the sun can actually excite what is there. So kind of like taking, a bunch of juice that's in a bottle and shaking it up. You haven't added any juice, but you've sure created a lot of bubbles inside of that canister, haven't you? You've really shaken things up. And in addition to shaking up what's already here, exciting it is the term you'd use if you're talking about energy. But it's also injecting that energy in the form of protons, electrons, and even some of the heavier particles, which are more rare. And essentially, all of these are integrating into the Earth systems in various ways. For those who know that Earth has a magnetic shield around the planet called the magnetosphere, so, some of the energy is caught in that and funneled towards the polar region. Some gets through that and hits the top of the atmosphere where there's actually a lot of charged particles, and it sort of trickles down that way. And so all of these things can really add to the Earth system and excite the Earth system. And we see this manifested as breakpoints in various layers. So we can see whenever these things really manifest and accumulate in the atmosphere, we see weather effects as well. But when they're able to really accumulate in the crust and there's either an overaccumulation or too rapid of a change, that's when you can see the water, the crystal, and the metal underground really begin to react to that.
And so how does that play into predictions of earthquakes? You've been quite a history, and I believe some of the observer followers of yours have been very successful at predicting some of the larger earthquakes on the planet. So how does all that information that we're receiving from this electricity factor of the earthquakes being used in predictions?
Well, so there's two sides to this. There's when's something big going to happen? When is today going to be the day when it's not just, oh, we have our regular random earthquakes, but today there was a big one somewhere. Things like that are knowable when you can tell, all right, is the sun giving us a ton of energy during that period? But then you have to figure out, okay, well, what part of the world is most likely to have this earthquake? And that's where things are still progressing towards the finish line. I'd say they're about halfway there right now. What we can do is using a lot of the electricity that is showing up in the atmosphere, which can take the form of not only just lightning storms, but of how the high and low pressure cells sit and how strong they are and how they move around. And so just literally high and low pressure, watching those things can really tell us where Earth's energy is surging the most. And you can oftentimes use some other satellite imagery. They have a certain measure that shows how much infrared radiation, how much infrared heat is coming off of the different areas of the planet. And you can oftentimes use that as well. And then, of course, there are force shock patterns, which are less about electricity and more about the fact that, you know, every time you want to throw a baseball in one direction, you got to cock your arm back unless you've got some kind of magic. And so if you think about an earthquake in that way, you know, an earthquake is like throwing the ball. You got to cock the arm back. You probably got to lift up your lead leg to sort of create that, you know, built up energy around your core. I mean, it's literally not until the very end of it that ball goes flying. There's a bunch of things that happen in your shoulder, your elbow, and your wrist in between that too, actually. And so that's how you could really think of the physical force shocks. There are patterns, and we have learned to spot a number of these patterns. Yes, we have had a lot of help from computer learning and spotting some of these patterns, but we had to spot some of them first and say, all right, computer, this is what you're looking for in the data. So it's really kind of like that.
And I've had your prediction app since the beginning too, so I have it. My brother lives in the Philippines, so I'm constantly basically trying to use him as a test run of whether or not he can feel certain earthquakes in certain areas as they're around there. It's interesting that certain parts he cannot feel them at all, and other parts similar in magnitude he can feel them significantly more. So it's interesting. But
yes. You mentioned that there have been people who have been doing this. So yeah, there are a couple of professors and one NASA scientist who have really gotten good at this. But also there's a guy who is a chef at a university lunchroom in Tennessee, I think. He's very good at this. And the guy who's probably best of all is a fisherman / farmer who lives in LA, just outside of LA. He fishes. He actually helps sell farming equipment. And he's the best earthquake predictor in the world in terms of using this that I've ever seen. I
guess there's hopes for me, like guys like me who's a bartender then. I guess I probably would fit right into there if I would focus on the efforts that they have done. So, go ahead.
Absolutely. I was going to say absolutely. Everything is at quakewatch.net, and that's where, I mean, literally in just about an hour, you can learn how to predict earthquakes. And like I said, anybody can do it, and they are. Excellent.
So, and just kind of, maybe this is something I should have started with first, because we've talked about electricity and magnetism here. What is our sun, actually? I know, back in, I guess, earth science, I was told it was a big ball of fusion, and it's just going to burn out someday. But I don't think that's necessarily fits with what we're talking about here. If there's we haven't mentioned what I think you've alluded to, the global electric circuit. So what is the sun in your estimation, and how is it different than what I was taught in 9th grade?
Right. So we know a lot more about the fourth phase of matter called plasma now. And I don't want to get too into chemistry or physics with this, but essentially the sun is such an energetic ball out there in space that for the most part atoms have been ripped apart into their protons and their electrons, and what atoms are strong enough to remain, some of the iron, it's not regular iron, it's been stripped of most of its electrons, and so it's got a strongly positive charge. It's missing all those little negative bits. There's a lot of guesses about what goes on underneath. There's a lot of assumptions about how it works. Really, the more we get into detail, the more we're finding that we've got one question answered and three new questions about the real nature of our star. And so we know there's a whole ton of plasma. There is evidence for some of the more condensed phases of matter, so almost like liquid plasma, as opposed to just being a ball of gas. It very much acts as though it has a real surface, like something solid or something liquid, as opposed to that ball of gas. And so many mysteries are coming up about the sun, and it's a time that I never would have imagined could exist. Having to go back and rethink so many things just by getting a new observatory or a new satellite. Something tells me that within a few years we're going to be rewriting a tremendous amount of science.
And I don't think that you would be accepted still, but if my memory serves right, you started maybe trying to pursue a meteorology career, and if so, if you had all the information you had now and you could enter that program today, would you still think you would have success? Not that you would bother trying to go through that, but
the problem is I had what we're getting today. What was required of me was that I acquiesce, was that I do exactly what the professor did when he was in college, and then do exactly what 8-10-year-old weather models were doing. And every time I would bring up some new paper or some new study that would say, hey, look, this is a real thing, we should be using this, that was just not something the professor wanted to hear. The concept that the professor didn't know, and multiple professors didn't know everything about the weather and weather forecasting, despite how often they got it wrong, was just an unacceptable proposition to their minds in general. And so I ended up getting in so many fights with them, and they numerous times suggested I find a different major. I found a different university, and yet somehow managed to find my way right back into earth sciences.
Sounds like a man of persistence. So very credit to you, I guess. And just on a side personal note, I've thought about asking you this question. What would, if you were, Al Roker, and you were hosting the weather on NBC News today or whatever the morning show is back in the day, and you could actually give the data and information that you thought was important to the people for the day, is there such a thing that you could incorporate from the space weather into a daily forecast and be like, hey, this is what you should be paying attention to as far as your weather?
Absolutely. And I also think that in this regard, it would be the weatherman's job to say whenever it was earthquake weather and whenever there were overall earth conditions that, are shown to have higher rates of stroke, of heart attack, of all kind of mental and psychiatric disease, whether that's episodes of hospitalizable depression and anxiety, or it's increased number of people who have reportable events in a psychiatric ward, something like that. Autoimmune diseases are related to this. Everything from how hard is that hailstorm going to be to how many tornadoes do we expect from this storm to, could this thing turn into a derecho? Where, what are the chances that the precipitation that the computer is guessing is going to occur is an underestimate, and we're going to have major flooding? Is this hurricane really going to stay on this slightly westward track, or is it going to bend north into somewhere? If it's kind of going north, could it do what Hurricane Sandy did and go back the other way? All of these things, from the earthquakes and whether or not your region is looking like it's at high risk, to the effects on what the computer models are thinking that your forecast is going to be, and how you would tweak that based on what the sun is doing. It would literally take into account so many of these. I mean, there are certain days when I would be able to say, hey, there's a much bigger chance of you having cell phone problems today. There's a much better chance of there being internet outages today. There's a much better chance of any number of things like that. There's a much better chance of there being significant delays in airline computer systems that are nationwide, things like that. All of this stuff is in the future of weather reports. And all they need to do is begin to use the data that they already get and apply the science that has already been peer reviewed and published. The problem is you've literally got 15 different fields of science converging on this thing. And, you know, the people in these different fields at the same university don't talk to each other, let alone all across the world. And it's really sort of a hodgepodge, and you really can't master or be a professor level expert in 15 different fields, which is what they really need right now. And I am not a professor level in 15 different fields, but I'm probably a postgraduate level in all of those different fields without ever having taken the time to, you know, literally become professor level in one of them. I'm just highly proficient in a number of these other ones, to the point where not only can I see the patterns between them, which a lot of which are in that book that I can see sitting on your desk right there, but you know, middle school classes engage with me on Skype on a regular basis. There's a couple of them out west and one down south, actually. And the kids can see these patterns in the data. And it's interesting with some of them, especially with, you know, sixth graders, the really young ones. You know, you do have to start with saying, hey, look at this line. This is showing you what happens at night and day, you know, something they already know and understand. This is how much light there is, and then at night it goes down. And or you could say this is how hot it is, and it's really hot in the middle of the day. And they can understand literally within 20 to 30 minutes what they're looking at within some of these patterns. And then you get to high school and some of the universities I work with, and these 17-year-old kids are crushing it, absolutely crushing it. There's one who discovered one of the now 6 major correlations between a solar feature called a coronal hole. Basically, it causes the solar, all those particles that I said were coming out of the sun, it causes them to come much faster than they normally would, those protons, the electrons, etc. He found a correlation between those and the number of tropical cyclones, and whether you're talking about tropical storms, hurricanes, Indian Ocean cyclones, or a West Pacific typhoon. All those things could be called tropical cyclones or tropical storms. He found this amazing connection, and he actually won the 2017 National High School Science Championship doing that. So this stuff is, it's there, and it's actually easy to understand. The problem is, because of how science is just this monster right now, it's literally like you have to find needles in a haystack or little gray hairs on a polar bear spread around its back. You know, they all look white to you from way out here. But if you know where those little gray hairs are supposed to be, and you can pick them out and you can find them, and when you have hundreds of thousands of people that are helping you search the internet and search journals, which is what we have now. This isn't just like people sitting there with their finger up their nose being entertained by something on their screen. These people, I mean, you have to come ready to have your mind very, very entertainingly and amusingly challenged. And it's a lot of fun. And for the people who get engaged, they find that they're able to contribute and help create this massive picture that now goes from everything from, you know, the cosmological physics of the universe down to how does the sun trigger earthquakes, things like that. So,
and that was awesome. And and we kind of danced around it a little bit, but Climate Forcing was one of the movies that you put out, and I would encourage everybody to go check out the 3 movies on his YouTube page. They were very informative and excellent done. I'm not sure if that's all your work, Mr. Davidson, but those videos are excellent. The Climate Forcing is something that I feel like is probably maybe the most divisive part of your research, in large part because there's so much political investment in one result being the right result, and your research kind of flies in the face of that. So let's jump into climate specifically. I know we touched on tropical storms and the high school science champion, but let's start with Congress coming after you about your climate report. I believe there was maybe a small handful of Congress people, Congress critters, and who tried to get you removed, your platform removed. Is that correct?
Yeah, it was the Congressional Select Committee on Climate Change. They identified mine and a couple other channels and asked Google to delete them. And Google being YouTube,
right.
As they own YouTube. It was a wonderful moment against censorship as while technically they said nothing, essentially Google was saying, you are not going to tell us what to do. And of course, my channel never went down. But that's just, of course, one of the things you have to deal with when you say what I say. And what's interesting is people like the politicians on that congressional committee or the professors who continue to take millions and millions of dollars and then just pander to the National Science Foundation and the media, is that the way I start all of this is by saying, look, we can have both. We can have our environmental goals and we can get the science right. I not only favor less pollution, but I favor retroactive cleanup measures. I favor stronger penalties for those who actually, have spills and who actually pollute. This is the one atmosphere, the one water system, and the one soil system we have to live on. And we can't poison it. But that being said, most of the stuff they talk about affecting climate change has absolutely nothing to do with climate change at all. And so if we can just put our environmentalist hat that is nice and pressed back in the bag for a minute, essentially there was this idea that carbon was the bad guy, and it's still being pushed and still being pushed. And if you actually look in the journals, you can see the face beginning to crack on that one. I don't know if it's months away or a couple of years away, but they're starting to figure it out and starting to turn the Titanic. This is not a jet ski of a field of science that they can just whip around in no time and go another direction. They are starting to turn the Titanic already. And you see this not only in some of the papers that come out, but the fact that there are universities that are using that textbook, Weatherman's Guide to the Sun. There are major geophysical conferences like the one from the American Geophysical Union that are now dedicating significant amounts of time and attention and respect, therefore, to how the sun works the weather. And they're mostly coming down to the conclusion that this idea they had where the primary solar input to the Earth climate system was light energy, visible light, ultraviolet light, things like that. Boy, is that incorrect. It's those protons and electrons and how the sun can actually excite what's already down here, shaking up the juice bottle. And that's really the direction it's moving. And what it really says is, while everybody seems to be looking one direction in the climate crystal ball, this cold princess is sneaking up behind us. And when the wool goes over our eyes, it's going to happen so quickly, nobody's going to have any idea what happened. Well, let me tell you what's happened so far. From about the 1940s to about 2005, we had the strongest solar activity in 12,000 years, since the solar activity that actually brought us out of the last ice age. And in addition to that, we had the lowest cooling from volcanoes. And by the way, they cool by blasting stuff into the upper atmosphere, which reflects sunlight, blocks it from getting to the ground. And it's the same idea: volcanic winter, nuclear winter. You put a bunch of stuff in the upper atmosphere, the sunlight can't get down here, we all freeze. We are at a 1,000-year low for volcanic cooling. And as if those two things occurring, the record high solar activity since the last ice age, combined with the low volcanic cooling, wasn't enough, happening during the period of global warming. But Earth's magnetic field that I mentioned, it is failing right now. It is in the process of going through a once every 10 to 15,000 year event, and it has been letting in much more of that solar energy as well. This has been the most unbelievable trifecta of warming that you could ever ask for on a planet. apart from, you know, some giant alien coming with a Jupiter-sized lighter and setting it on fire. This is unfathomable. And the thing is, they are all about to shift gears into a different direction, because the sun is coming out of its grand maximum phase, and it's very much descending into a grand minimum phase, which should happen probably in about 10 or 20 years. It should get down to that grand minimum level, and it's probably going to stay there for 20 to 40 years. Now, that's going to drop the amount of solar energy that's coming in, but it's also going to allow what they call cosmic rays. And all you really need to know is this would be from things like supernova far away, those tiny little particles that you know, make it all the way through space. Well, those are coming at us from all directions, from supernova, from the birth of stars, from collisions of stars, and other things like that. Basically, the universe is filled with these things flying in all directions. And because they are, again, electromagnetic, think of it as if you put two north or two south poles of a magnet together. They'll actually push apart. When the sun is really active, that electromagnetic energy pushes out or keeps out a lot of the cosmic particles from the galaxy and other galaxies. When the sun's not doing its job, we see those particles surge on the Earth. And we do know that when those actually break all the way through the atmosphere and get to the mantle, they excite silica-rich magma, which is most of the explosive volcanoes on this planet. So one of the reasons we probably had such low volcanic activity is because the sun was blasting so hard. And here's the other thing. When it's those cosmic rays that are coming in and not the solar energy, which tends to produce heat, those cosmic rays tend to produce clouds. If you've ever heard of a cosmic ray cloud chamber, a lot of students get to play with those in classes nowadays. And so one of them causes heat and the other one causes cold. And so we've basically gone from super high solar energy, super low volcanic cooling, with more of that super high energy coming into Earth, to now we are transitioning to less solar energy, more excitement for the volcanoes, which, by the way, throughout history have never shown periods where they sleep forever. And all at the same time, that those cosmic particles that are coming in cool the planet with reflective clouds. This is coming up on us this century. I mean, most people listening to the show, certainly our children, are going to be dealing with a much colder world. And most people aren't going to have any idea what hit them, what happened to this planet.
Yeah, I live in, I don't know if you know, I live in Syracuse, New York, so I feel like I'm at the, I don't know if the epicenter is the right word, but I feel like I should be moving it between now and the next 10 years. So that would be a fair assessment on your part?
Yeah, well, I'll tell you what, you guys do some good snow studies.
Well,
for sure.
I guess lemonade thing, I feel like, is a joke in there or something. You know, that's what we deal with. So, Mr. Husong, so after hearing a little bit of Mr. Davidson's data here as a newbie, as your self-proclaimed newbie here, what questions would you have as somebody who's being exposed to a large amount of this for the very first time about either earthquakes or climate? What questions would you have?
First thing I want to do is I want to back up a step. And earlier you mentioned how the sun and the whatever's coming in from space can help indicate higher levels of health issues, immunocompromise, whatever it might be. Could you explain a little bit more about that?
Yeah, absolutely. So most people know that, or at least have some general idea that your brain activity sending signals throughout your body is an electrical process through your neurons. But there's actually twice the electric power in your cardiac system with your heart. Almost everything that happens in your body requires what they call an ion channel. This is why electrolytes are so important. Electro is the important word there. These are all things that help your muscles move, help your heart pump, help a cell know what's supposed to come in, what is supposed to go out, the energy needed to pull things in, to push waste out, to send blood, to carry oxygen. Literally everything we're talking about, everything that makes you you and makes you live, requires an electromagnetic component. And when the electromagnetic environment of yours changes, this can have a major effect. This is no different from, say, I got too much sunlight, now I have a sunburn. Or, oh, I spend too much time living under power lines and working with, high energy wires. I got, radiation induced cancer, something like that. It's not all that different. If you get hit by lightning, that's an electric event. It can stop your heart. It can start it again. They'll blast you with the human version of lightning to try to start your heart again if your heart stops in the hospital. All of these things can really tell you just how electromagnetic and how dependent you are. If you know anything about sports, you understand how important electrolytes are, and or at least you've heard that you need them when you're trying to refuel or when you're trying to, get the gas back in the tank. And there's a reason for that. And there's a reason why, honestly, the difference between, something like Gatorade and water, what they noticed at the University of Florida back then, it wasn't just the energy, it was the injuries. It was a drop in injuries, simply because their muscles had all the things they needed to do what they wanted to do. And so everything from the beat of your heart to a cell doing what it's supposed to do is all based on electromagnetism, all of it.
I see. And so the activity, the electromagnetic activity from the sun then has a direct impact, or I guess not direct impact, that might be overstating it.
No, but you're actually pretty accurate. So some of these particles can directly come in and directly interact. The light from the sun certainly comes in and directly affects your skin.
I'm Irish, so it gets me really good.
Yeah, it also affects melatonin production. But the other thing is, when the sun really gives the Earth a good whack with a solar flare and a coronal mass ejection, the kind of thing that lights up the northern lights, the auroras, it is also doing a number of other things. Whatever side of the sun, or whatever side of the Earth is facing the sun at the time when it hits, they're having an increased number of electrons pushed down through the atmosphere. Everywhere on Earth is having an increase in the amount of electric current that is running through the atmosphere. Everywhere on Earth, provided you are on the ground and on the surface, is subject to a change in the low frequency radiation of the planet. The magnetic field, when it gets dinged, our magnetic shell resonates, and it changes the natural electromagnetic frequencies that we're living in. And so all of these things end up coming through, and we directly interact with them. A good number of these things are that electric current that I mentioned, and the magnetic field resonance, which is again in the ULF, the ELF, the VLF, the low frequency ranges. And all you have to do is start looking through some journals, or even Googling, ULF, VLF, ELF, and human health. And you start to realize, wait a minute, the sun's basically just got a tuner. And, based on how strong it hits us, that's how far we deviate from natural. And all these things are what we live in day to day. And so you got, a few people walking together in a group. Yeah, chances are you're not going to really notice the whole thing. But when you've got millions of people, in a country, and you've got millions of data points, you start to see, wait a minute, these types of events are going up on these days. Is this random, or is there something happening? And they've known about these random surges in event days for, over a century. But it really wasn't until some Russian studies about 2 or 3 decades ago, and which didn't really start in this country until about a decade ago, they're starting to realize that, wait a minute, all of these problems can be explained by changing electromagnetic environment. It's like they all got hit by mini lightning at the same time. It's like they were all in a radio cavity exposed to the same electromagnetic frequencies at the same time. All of these things are noticeable now that we have better data systems and more people to get data from. And they're noticing that, yeah, these things really do affect our health. And it's one of the reasons that the disaster prediction app exists, in addition to notifying about earthquakes, which most people turn off because there's too many earthquakes on the planet every day to keep up with. But it tells you when there's solar flares. It tells you when there's, when the planet's magnetic field got hit by the sun. And it also, to my knowledge, is the only space weather or solar-driven health alert system in the world. And so those times when people who are in sensitive groups are at high risk, If you got the app, you're going to know about it. And believe it or not, just knowing about it can help you, feel your way through a situation. A lot of times when you have anxiety, for example, a lot of times you don't even know why you feel anxious. But if you can easily just sort of say, okay, wait a minute. I just got this alert about what I'm feeling on my phone. Let me look myself in the mirror and know I got this. The placebo effect works. It really does. It takes out billion-dollar drugs at the FDA level every year. And if you think about what the placebo effect really is, there's no reason for what happens. You didn't actually take any medication. You didn't actually take the thing. It's just your brain thinks something. And all of a sudden, just because you had the guts to think something, chemistry and physics inside of the system you control no longer matter. And what you think becomes reality. That is magic. And unfortunately, that same level of magic you have can seem to be the same level of magic. What, a solar flare is going to cause me to have a heart attack? Well, no, not everybody. But if you've survived a heart attack and you still eat like crap, yeah, maybe you want to pay attention when there are solar flares. Maybe you want to sit down and not go for a jog. Maybe you want to put the cheeseburger down and get a salad that day, kind of stuff.
Maybe it's time to skip that second Baconator is what you're saying.
Yeah, and it can be something as simple as there was a gentleman who their doctor was telling them to take low dose, like baby aspirin on a daily basis. He never, ever did it. One day he got the alert on his phone. 2 hours later, he was feeling pressure in his chest. He popped a baby aspirin, called 911, and the people in the ambulance, people in the hospital, his doctor said, the only reason you're still here is because you took that baby aspirin that day. And he said, the only reason I took that baby aspirin and listened to you that day was because I got that app alert on my phone. And unfortunately, welcome to America. It's one of the things that comes with our lovely freedom, which I wouldn't trade for anything, but this is what freedom can manifest in sometimes. And so there's a number of things. There's a tightrope walker who does tightropes over like 900-foot death drops, but he won't do it if the cosmic rays are too high because he knows they're pounding his hippocampus and other parts of his brain. He won't do it if the cosmic rays are too high that day. So it can be everything from an extreme example to the everyday Joe.
Cool. I was going to say that holds like a mind over matter in real practice.
Yeah, it's magic, and everybody can do it.
Mr. Husong, any follow-up here? Because I have a question from one of our super fans.
I got a ton, but in the interest of time, let's keep going. I'll circle back later.
So I got an email from one of our fans here. She wants to know, do black holes exist? Is that something you can answer for superfan Claire?
So they don't exist in the exact way that they thought existed 10 years ago, or what you may have learned in school. Heck, what we think we know about black holes is changing by the week. And looking a good bit ahead, I think that very, very little of what was originally described as a black hole is going to end up being real. It's not as though, there aren't those supermassive compact objects, but they certainly do not, they're certainly not the things that are described, access to wormholes, an inescapable force that even light can't get away from, those things aren't real.
Excellent. Okay, so let's take this big picture as big as you possibly can. Well, maybe not as big as you possibly can, or maybe it is. Let's talk the third movie of your series, the Catastrophe cycle. We go back to the sun, where we started. We have redefined the sun a little bit here. It wasn't what we thought it was in Earth Science class in ninth grade. We're finding out, or maybe you're finding out specifically, that there is a ever increasing number of what are being called, or what are called, recurring novas. I think you may have coined the term micronova, but I feel like they might just actually be the same thing. And can you start with what a nova or a micronova or a recurring nova is, and then we can go on how that will affect the Earth from there?
Sure. So they've started to notice as they were watching stars that they had known had nova, and then they're like, wait a minute, it looks like there's still a star there in the middle, and then it goes boom, and then it goes boom over and over again. They've seen some go boom 7, 10 times. And the thought process now is that every nova that doesn't destroy the star is going to recur, and it can be on this level of a year. Like there's one in the Andromeda galaxy. Every Earth year, it has a miniature nova, to millions of years apart, and they can be as big as supernova to something where there's like a snake-like shedding of its outer atmosphere shell, where the blast that we look at might be very high in X-rays, for example, but the actual shock wave of the nova would barely get past the orbit of Mercury. And so we have seen all different scales of recurrence. We've hypothesized that these scales of recurrence go out to millions of years. We have seen everything from super huge supernova down to things that wouldn't even, recurring events that wouldn't even destroy Mercury. Yeah, they might bake them with X-rays whenever the shell released, but at least it wouldn't, break the planet apart with a supernova shell. Our sun is somewhere in the middle of that. It is likely the reason why we have this weird magnetic reset on the planet every 10 to 15,000 years. Unfortunately, it is just a very few isotopes that we keep finding in these layers that tell us it had to be some kind of stellar nova event. There's no other way to create these isotopes. We also know that they don't live that long, and so they couldn't have been here before the Earth formed, before the solar system formed, and they didn't travel from a nearby star that went supernova, even a very close one that went nova. It would still take the thing millions of years to get here across the distance of space. And so we know that we need a recent, nearby, and apparently, due to the layering, recurring nova event. And since something like that at another star we would notice, or we would be destroyed by if it was an actual supernova, we're talking about a recurring micronova event from the sun. And this would go and help explain a lot of the stories about ancestors, regardless of where they lived and what gods they worshipped. They always tend to point to the sun as a destroyer and a bringer of life. In Egypt specifically, they've got a couple of pharaohs in deep history that use the black sun symbol. It's in Christian prophecy, and there's chemistry and physics to back up how it would all happen too. In fact, in the years/weeks leading up to it, in terms of the 4 horsemen of the apocalypse and the colors, they actually kind of fit with the sun, how it would go down at the sun, starting with the first one being years ahead of time, and then the last one sort of in the last couple of weeks, days, so to speak. Just to give you an example, I mean, imagine somebody asked you today what color the sun is, and you can bring yourself to actually look up there. And if it's anywhere near the top of the sky, you can't say it looks yellow. You just can't. The sun doesn't look yellow anymore. It's white. It's so bright it wears a crown up there at the top of the sky. And that's one of the first, signs are changing. And it's not that the sun is necessarily changing so much, but the entire solar system is going through this magnetic event. We see evidence on Earth with our magnetic field beginning to change. We see the sun beginning to change. We see these sort of weather changes and auroral, northern lights-based changes on other planets that you would expect if they were going through magnetic changes. And so one of the first things we're going to see is, through our changing magnetic lens, the sunlight looks different. Remember, light is just electromagnetic radiation. Yes, our magnetic shell around this planet affects how we look at space, how we look at the sun, how we see light coming through. And so there's literally, at the top of the sky, every single day, a sign that, hey, look, this is not what you grew up with. I'm here, but I'm wearing a different costume up here now. Do you like my crown? And what's going to happen is, there's going to be a very powerful X-ray event, and there's going to be a shock wave that does get to Earth. It's not going to destroy the Earth, but it's going to bring things like meteors and very powerful electromagnetic whacks like we were describing earlier. And there's very little chance that we won't be thrown back into the Stone Age when it happens. And there's really no other way to describe it. It's the kind of thing where we see the evidence of this happening about every 12,000 years. I like to be a little safer and say 10 to 15,000, but really it's about every 12,000 years. The last one was 12,000 years ago, and we're currently experiencing very strong magnetic changes on the planet in the precise way one would expect were such a 12,000-year event to happen again. We see it in the weather. If you've been watching this week or at all really this summer, you know that Earth has pretty much changed how it does lightning. We're sort of in an Earth discharge phase where the lightning is becoming much, much more extreme. They're happy to blame it on global warming. The problem is there's nothing about their version of global warming that should increase lightning. Certainly not like this, certainly not this quickly. You know, we had been expecting another geomagnetic jerk, they call them, in Earth's core last year, this year, and I think we're seeing the effects of that now. We already had gone from losing 5% of this planet's magnetic shield every century to 5% a decade or so, and that was in the last 10 to 15 years. If we've had another similar event, we're not talking end of the century, we're talking a decade from now.
And you mentioned here as a weakening magnetosphere, that also goes with the magnetic pole reversal, I believe.
Exactly. So you may have heard that, you know, they have to update the world magnetic model. They have to renumber airport runways. They're having to do all of these different things. And they're always trying to quell the fear and saying, oh, well, this is because of the change in Earth's magnetic field, but don't worry because of this reason or that reason. And literally that part of every single one of those articles and news stories is complete poppycock, complete nonsense. It's really the core of the story that's important, and that's the real thing. Where if you're actually seeing this, I mean, anybody can Google, world magnetic model. Re-update. They had to do this huge re-update last year because military planes and commercial airlines are noticing, hey, our telemetry's off here. You know, you guys need to do a better job with this. Now they'd get on local systems and be able to be guided just fine. But they're having to do this more and more often. They're having to renumber runways and other things like that more often.
So is there, I was going to say, so along with renumbering airports, which seems like a somewhat mundane task to do, are there something more serious, something more devastating, if you will, that could happen from a weakening magnetosphere and a magnetic pole shift? So just like normal, we had a number of solar storms this last sunspot cycle, the earlier part of this last decade, that caused major technological disruptions. Things like they had to take all the planes out of the sky over New Zealand at one point. This is something that we see every sunspot cycle. The problem is the sun didn't do anything this last sunspot cycle that should have made that happen. It was all weak space weather, so to speak. And so basically what you're looking at is with our shield going down, it's taking less and less to cause these technological disruptions, to cause these earthquake disruptions, the weather disruptions, the disruptions to our health system as well. And when the magnetic field gets to a certain point, there will be no more electricity going through copper wires. It won't happen. There will be no more cell phones. There's going to be no more AC, no phone, no refrigeration, no food at the store. There's going to be nobody to call. There's no police. There's nothing. There's just you and everybody else around you who's hungry and thirsty. It's going to throw us back into the Stone Age. If we get to a certain point and we get a really good blast from the sun, every copper wire on the planet will melt and burn down every structure that they're in. And some people have heard of the Carrington event. I know you have. If something like that happened today in this state of magnetosphere, I'm assuming that would be even a larger impact than just frying the telegraph lines?
We're done. And they expect that one every 150 to 200 years. It was, 161 years ago? We're on the clock here. Now, in the past, it was just a fun light show for the people. Maybe there were a few more heart attacks or strokes among the native people, the indigenous folks. But now we depend on electricity. We have built our homes with, burn down mechanisms if we get the same kind of surge of electricity that we see, that we know is going to happen again. When this thing happened in 1859, telegraph wires caught on fire. They were unplugging the machines and still receiving telegraphs. They didn't need the electricity from the source. They were getting it from the atmosphere. Operators got shocked. Like I said, a number of buildings burned to the ground. Now, back then, there was really just the telegraph wires. There wasn't a whole lot to destroy. In fact, most of the people who had their homes destroyed or catch fire, they were Richie Riches at that point. They were the only ones who had electricity in the house. We all do now. And it's all on an interconnected circuit where a disruption anywhere will release the entire energy stored within that circuit explosively. Okay. And that's what we are seeing happen. That's what Quebec found out in 1989, when there was something about, 10% as strong as the Carrington event in the 1859 era. The entire province of Quebec lost power. If we get something like that today, probably the entire world's going to lose power, but it'll be like a reset and rebuild the transformers that are damaged area. If we get the Carrington event, something we know is going to happen again in the next couple of decades, if not something bigger like that micronova, it's over. We're cut in half. There's 100 reproducing females left on the planet type thing.
I'll make sure to sell. I have to sell my Bitcoin before then.
Yeah, well, definitely. And, we've been there a number of times on this planet. When this happened 70,000 years ago, they think as few as 40 reproducing females survived in the human species. And we made it back in really not that long of amount of time. So, that's, of course, worst case scenario. But, we even if we hope and can pray and get lucky enough that the sun doesn't do something so terrible, we're still losing the magnetic field. And eventually, just like last cycle where we had, the normal 5-6 events where we had a solar-induced technology disruption on a major level, I'm sitting there watching the sun being like, from where? What did it do? Like, we took 1,000 of those the sunspot cycle before and didn't see any problems. We took 1,000 of those the sunspot cycle before that and didn't see any problems. What the heck was so special about these? And I finally had to just come and admit it, that it's not anything special about these. It's that the Earth's shield is weakening to a point where we are vulnerable. Scotty says the shields are down.
Worst case scenarios with the shields down. We get this thing. Obviously, you said back to maybe 100 reproducing females. Is it just the sun-facing side, or
no,
is it much bigger? Like what's the series of events that happens following a micronova shell release hitting the Earth in a weakening magnetosphere? How do we get to the other side of that?
A lot of people will have to be under the ground because there's going to be cosmic rays, and probably, a lot of what we see in nova shells is silicon dioxide, sand, glass. There's literally going to be glass beads and sand raining from the sky, melted in some circumstances. The kind of super lightning that a man named Robert Schoch thinks knocked off the back of the Sphinx could be seen in various places. In fact, we're almost getting there with the lightning now. The kind of stuff that made the ancestors invent the god Thor and other lightning gods and things like that. There's a reason. These people weren't stupid. They invented geometry, philosophy, architecture. These are the geniuses upon which we've built our modern world. And yet we take the story that they say is the most important, the one that they demand we don't forget, and we're like, that was their fantasy. They just made that stuff up. I don't think so. They saw something that was outside of the realm of real for them, and they had to blame gods. And we're going to do the same. I don't know about the second part, but we're going to see something out of our realm of experience.
I'm guessing we're going to need a lot of some luck to get through the second part. And that might just depend on where you are at any given time, I think. So, Mr. Davidson, I want to thank you for your time, and I want to wrap up here real quickly. If there's anything that we missed that you want to make sure that we touch upon for the audience here that we may have just glossed over or didn't touch on at all.
Like I mentioned, really what you need to know is there's a terrible thing that happens on this planet about every 12,000 years. The last one was about 12,000 years ago. Everything you'd want to expect to see, all the boxes that would need to be checked to tell you, hey, we're on that same path, they are all checked, including a bunch we wouldn't even have thought of until we saw them. We're like, oh my goodness, it's so bad. That's happening. It's happening right now. It's going to affect everyone on the planet, and it looks like, you know, even before the big show, things are going to get bad. And that time is probably not decades away. It's probably this decade. Something is going to happen, and the world is going to have to realize, wait a minute, something's not right. And when that happens, you think the narrative has changed in 2020. Wait until the sun and the earth turn their back on us. You haven't seen anything yet. And if it seems like people are losing their minds, well, their minds are existing in a changing electromagnetic environment, a very changing electromagnetic environment, and you haven't seen anything yet.
That sounds very scary.
It is a little bit.
Any chance you want to end with some hot Jeffrey Epstein take?
What about Jeffrey Epstein?
I said, do you want to end with some hot Jeffrey Epstein take?
I'm
like 70-30. He's still alive. You have any comment on that?
I don't know if he's alive or dead, but he didn't kill himself in jail. That's nonsense. It's complete nonsense. Yeah. Just like I don't believe for a second that Ghislaine Maxwell was like, 2 miles away from the FBI office there and they didn't know it. Yeah, they knew she was there. They just didn't want to tell people she was in technical custody because they were afraid someone was going to kill her. That's something I believe. Yeah.
We like to touch on that. We like to try not to let that story go because I feel like it's, even though it seems like it's been going on for decades, it's just kind of bubbling to the surface here. So I like to get some people's takes on that.
Every once in a while, I will throw in an Epstein didn't kill himself into my morning show.
I've seen them.
It has been known to happen every once in a while just for fun.
I have seen them.
I don't like actually talking about the article that I'm supposed to be talking about. But anyway. They're
appreciated. And I want to appreciate your time again. Like I said, it was a privilege to kind of pick your brain here a little bit, and I'll be in touch for sure.
Absolutely. Well, you have a great rest of your day.
You do the same. Thank you, Mr. Davidson. Take care.